Welcome back, people. This is going to be the third video in the series of programming player missile graphics, also known as sprites, on the Atari 8-bit line of computers. So today we're going to further advance the topic. We're going to be modifying our last program where we created a spaceship and moved them across the screen with some background objects, and we're going to tweak that a little bit where we can now fire a missile from the spaceship and have that missile collide with a background and also another player. So we're going to learn a little bit about how to detect collisions and firing missiles and a bunch of good stuff. Good stuff you need to learn about if you're going to program on the Atari. So stick around. It's going to be fun. Don't go anywhere. So before we actually get into the code, let's just talk about what we're doing here. We're writing this stuff in BASIC, and as you know, BASIC is slow. So what we're going to show today is going to be slow. You can't really write a very fast arcade style game in BASIC, but I like teaching some of this stuff in BASIC because it's an easier segue into the topic at hand, which is player missile graphics. Eventually we're going to move a lot of this code into assembly language and develop some real speed and power that we need to make the game run at the speed that we want to see it run at and that we want to play it at. So just keep that in the back of your mind. Everything we're doing in BASIC, I'm going to port it to assembly language so that we can really see and get some awesome play out of the game. That being said, we have incorporated some assembly language into the BASIC code just so we can get some basic play out of it. Otherwise, it would just be too slow to do anything. So keep that in mind, guys. I'm not sure if this is going to be the last in the series of the player missile graphics because we have covered most of what you need to know to get started and to get your feet wet and to get running with it. There might be one more where we can show some tips and tricks on showing multiple sprites on the screen at once. Maybe some other stuff along those lines before we get into the assembly language. We will see. But in any event, let's get into this code and I'll show you what I did to the code. And give me some comments if you like the video or if you like what I'm doing, or if you have any negative comments or suggestions on how I can make them better. Make sure you add those comments down there. I do read them. I do pay attention to what you guys say. So without further ado, let's get into the code. Alright guys, we're back here at the 130XE and I've got the code listed here for what I'm calling player 1C listing. I am going to include this source code up on the website as I realized that the last two tutorials did not have the source code up on the website. So I will definitely include this source code on the website, www.8bitandmore.com. You can go there and download the source code and be able to use it on your machine if you don't feel like retyping it. But in the meantime, you can see here, this is the code modified from last time. I cleaned up the comments, the remarks a little bit. You'll see new lines of code in here. You'll see some new variables, and I'll go through this code in a minute here and show you exactly what it's doing. But the first thing we want to do is run it and see exactly what's changed from the last version. Now, if you guys are just watching this video for, and this is the first of the series, there's actually two videos prior to this one, okay? And I'm going to put the links in order right now at the top of this video. The first link is going to be for the first version of this tutorial for player missile graphics, and then the second link is going to be the second video in the series for the tutorial on player missile graphics, or sprites, commonly more known on the Atari computer. Highly recommend you go look at those before you watch this one. If you're already comfortable with player missile graphics in the Atari, feel free to watch this one right now. But if you go look at those prior videos, it'll explain this code and how we set it up. So anyway, I got my monster joystick here. Let's go ahead and run this code. Let's see what happens. So now you can see in this version here, our spaceship is at the bottom like it was before, but those color bars, I moved them up horizontally at the top of the screen, and I've added an alien in a green color that's actually going across the screen from left to right. I hope this looks good on the capture device because I have not seen this yet. So, but in any event, we can, like as before, we can move the spaceship left and right with a joystick. I disabled the code to move it up and down because I really wasn't concerned with that for this tutorial. But what we did add is a fire button. So now if we press the fire button, we actually launch a missile. And you can see that missile going up, and when it strikes that orange wall, I don't know if you can hear that explosion on the camera. Let me fire another one so you can actually hear that sound effect. You can see how things slow down when you have multiple objects on the screen going at once. There we go. Do you hear that crashing sound? Okay. Now, that will detect anytime that missile, what we're doing is I'm actually shooting a missile from that spaceship, and it's going up until it detects a collision with that wall and then removes a couple blocks from that wall to show that it got hit. Now, I'm going to see if I can hit the alien. If I can, hopefully I can force the missile to slow down. No, I'm not going to miss him that time. Let's try that one more time. Let me go back here in the middle. Let me see if I can time this just right where I can hit that alien. I might get him this time. Yeah, I'm going to get him this time. So you can see when it detects when it hits the alien as they're moving until they're actually free from each other. All right. So I wanted you to kind of see how and what this code is doing. If you fire a missile and it hits a valid piece of that orange wall, it's going to remove the wall and give you an explosion. It actually didn't do it that time. There might be a bug in the code. Let me move over here a little bit and see if it detects it this time. And the survey says, oh, there we go. All right. So, and if you actually hit the alien with the missile, it doesn't actually remove the alien. I have it set up just to continually give that sound while that missile is in the vicinity of the alien, so you can see. Oh, just barely got him that time. Barely missed him that time, actually. Let me see if I can do that one more time. Looks like we're going to get hit this time. Oh. I can't time it right. Let's try that one more time. While we're hitting the alien, it continues to detect a collision until it's actually out of the path and not touching the alien. As long as that missile's touching the alien, you're going to get that explosion sound. Let's see if we can get this to hit. I think we'll probably get it this time. Nope. You can see how slow things are going under Atari Basic, which is the reason why we're going to port this game to assembly language before it's all done. There we go. So you see, as long as those two are touching, we get that collision sound. Okay. So let's break the code. Okay. So let's start with the first few lines of code here. So obviously, let me turn this sound down so we're not being bombarded with cursor sounds. Let's go up here. Here's a comment, a comment, a comment, a comment, a comment. Now, as we had in the last version of the software, we've got a couple strings defined here. MVPLUP string, that stands for move player up. That's 27 bytes of assembly language, machine language code that I've built in some prior videos to actually, you can call this from BASIC and specify a memory address in memory that will actually move that memory block up in memory. Okay, so in other words, if you have a bitmap stored in memory at a given address, this routine will move that bitmap up up one line or up one byte in memory in its entirety and that allows us to move the sprite upwards in memory. Okay, and this is the actual assignment of the string, and there's a video. I'll create the link now. If you guys want to see what this means, all these ASCII characters here and how we embed this into BASIC, this is actually a small machine language program that's embedded inside a string. These are all the opcodes and the operands for a small assembly language routine that moves a sprite up in memory. Line 70, another similar type of routine, except this one I call memclear. This is a machine language set of bytes that actually you can specify an area in memory address wise and the number of bytes, and it will write zeros to that memory. It basically clears it, and we use these two in this basic program. The first one to move the spaceship up and we use this one to clear out the spaceship in memory when we first start the program. So let's go down to line 130. Now, as before, in line 130, we set up some variables that we use to track certain states of the program and certain objects in the program, items if you will. VPOS P1 stands for the vertical position of player 1. 220, this is the starting position of our spaceship. The VPOS P2, this is the start. This is a new variable that we've introduced in this program. This is the vertical position of player 2. Player 2 is the alien. Player 1 is the spaceship, and player 2 is that green alien that you saw on the screen. So the alien is going to be a little higher on the screen when he starts off than the spaceship, our spaceship. HPOS P1, this is the horizontal position of our player, our spaceship, 120, which is roughly in the middle of the playfield. And we've also got the horizontal position of player 2, which is the alien. Now, since the alien is scrolling across the screen non-stop from left to right, we're starting him off the screen in position 0. Remember, when you're dealing with player missile graphics, the player missile graphics coordinates and colors are independent of the graphics mode you're in. You'll see here, actually you can see down here at line 170, that we are in graphics mode 3. In graphics mode 3 on the Atari, we are dealing with 40 by 20, a resolution of 40 characters wide by 20 characters in height. As far as the player missile graphics system goes, the players and missiles, there's actually an extent of 0 to 320 on the x-axis and 0 at the top to 256 on the y-axis. So you have a much finer or much wider range of numbers, x coordinates, and also y coordinates in the player missile graphics coordinate system than in the actual graphics mode that you're working in. Okay, and that causes some confusion sometimes to people that are just starting out with player missile graphics. They think that, you know, the graphics mode they're in, it's the same coordinate system as the player missile graphics. It's not, so you got to keep that in mind. So we're setting the alien, which is H position for player 2 to 0, so he's going to start off of the screen before he starts scrolling to the right. The height, P1, height of player 1, this is the height of our spaceship, our purple spaceship at the bottom of the screen. Six lines, if you will, 6 scan lines. And the height of player 2, which is the alien, is actually 8. Now we got one more position to track, which is the vertical position of M1, missile 1. That's our actual missile that we are firing up from our spaceship. And we're starting him at 0, and the horizontal position at 0. And the height of that missile is just 1 scan line, or 1 line high. Okay, so that's what these variables are tracking. They're tracking the vertical and the horizontal positions of our spaceship, the alien, and also our missile. So now we're going to get down to line 140. As before, we have to set up our player missile graphics base and memory. That's what this let statement does. We won't go into this since we already explained it in the prior video. We change our graphics mode to graphics mode 3 plus 16. The 16 actually gets rid of the small text window at the bottom of the graphics modes so that you have a full screen of graphics mode 3. And immediately we go sub 1000. Now 1000 we added in our last version, and what it does is this routine right here draws the stripes at the top of the screen, the blue and the orange wall, if you will, or ceiling at the top of the screen. I'm not going to get too in depth as to how this works. You know, we'll probably cover the plot and draw to commands in another video. I would say that most people, if you're doing player missile graphics at this point, you've already touched on basic graphics on the Atari, such as plotting points, drawing lines, setting colors. So we don't want to get too big into that. But this is a routine that basically draws the lines at the top of the screen, and then obviously it returns back control up to where it's called from. So again, we draw that background, and then right away we assign our player missile graphics base to the new top of memory that we set up. and we basically tell the operating system, hey, this is the new top of memory here. Again, the prior video, we talk about this and what this does. This line right here sets our single line resolution mode. Refer to the prior video once again. This POC 53277,3, this enables the player missile graphics subsystem. You have to enable it before you use it. This sets the player priority. Again, the last video, this talks about POC 623 and the values 1 through 8, and basically this controls the player's movement as if they are in front of or shown behind certain colors on the background. So in other words, in the last video we had an orange, we had a blue, we had a green stripe, 5 of them. And when we flew the spaceship across the screen from left to right, you would see the spaceship go behind certain colors and in front of certain colors. So that's what the priority does for there. Line 330, we're setting the color for player 0, which is our spaceship. Line 332, we're setting the color for our missile. This is new. Our missile is going to be bright white or bright orange, which I think is 255. So 705 is the color register for missile number 1. Let's go 336 on. And this is new to us on this demo as well. POC 706, location 706 is the color for the player or missile number 2. All right. And line 350, we're setting the initial position for player 0, which is our spaceship. We're setting him to 0. And we're setting the initial position for our player 2 to H position P2, which we already know we defined up top as 0. All right. We talked about this, setting the width of the players in the last video. You can have your players have a normal width, a double width, or a quadruple width to almost simulate them getting closer or farther away on the screen. So 53256 is for player 0. We're setting it to normal width. And for our player 2, which is our alien, we're also setting him 53258 to the standard width of normal as well. All right. Now starting at line 430, what we're doing is we always want to clear out the bitmap data and memory from our players, especially when you're first starting the program, just in case there's some garbage in memory, or maybe something was sitting in there from an initialization routine that you didn't realize. We want to basically go in there and we're saying P1 equals our player missile base plus 1024. Now if you don't know what this means, I'm going to put the slide up again here right now that shows our memory layout for our player missile graphics in single line resolution. And you'll see that our player base is at the bottom, and then 1024 bytes up, we pass the unused area and the missiles to get to our first player in memory. So plane 1 is the player missile base plus 1024. And we're using our little memory clear machine language program here to actually clear out that memory. We're saying clear out the memory from player 1, 256 bytes. Okay, now remember your players are 256, or can be a total of 256 bytes in height, okay? Each line is 1 byte. 1 byte represents 1 line of your player, 8 bits. And we're gonna do the same thing for player 2, which is our alien. We're clearing out his location. Now player 2 is actually the player base plus 1536. Again, refer to the slide. You'll see that we add 1,536 bytes to the base to get to the part of the block of memory that we've set aside for our player missile graphics for our player 2. And now we're also going to clear out any missiles that we have, which the missiles are located at player base plus 768. And that will clear those out as well. So we know we're starting out with clean players, no data to find, no bitmap data to find. They're just clear in memory. Okay. So now we're gonna go to line 470, and what we're doing here is we're gonna say, okay, we're gonna basically fill player 0, which is our spaceship. Okay, so we're gonna set up a loop here, and we're gonna tell the loop, start in memory where player 1 is, again, PB plus 1024. So if you think of 256 bytes in total for player 1, here's the start of player 1. We want to move down in that 256 bytes to where his vertical position of P1 is starting. Now we started vertical position of P1, if you remember, at 220. So 0 is here, 256 is here, 220 is roughly 3/4 of the way down, and that represents our spaceship. If you remember on the screen, he's a little bit more than 3/4 of the way down on the screen. Remember, our player is a vertical strip in memory, on the screen memory, and where you put that player in that vertical strip is where he shows up on the screen. So we are saying the beginning of player 1 plus his new position, 220, to player 1, his new position, plus whatever height he is, which we know he's 6 bytes or 6 lines in height. And we're going to read his data from our data statements, which is further down in the program, and we're going to poke his data into the memory and loop through it. So we're going to loop through 6 times, and we're going to basically build this bitmap I'm going to show you right now on the screen, which represents our spaceship. Okay? And I'll show you those data statements here further down in the program that represents that spaceship. I believe they start down here at line 880. Yeah, here we go, right here. Let me just isolate this so you can see it. All right? So this happens to be our data for our spaceship. 1, 2, 3, 4, 5, 6 bytes. And if you remember, I said earlier, our alien is 8 bytes. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? So let's go back up to 470. So we are filling player 0's data here. This is our spaceship. We're going to go right into the next one, which is filling player 2, which is the alien. The alien, this is his bitmap. We're going to start him where player 2 starts plus his vertical position. And we're going to extend to where he starts his initial vertical position plus his height. We always subtract 1 here because we're doing zero-based indexing. If you're wondering what that -1 is for. So we read the data, we poke it, and we're going to set his initial position to his horizontal position, which we know is 0. So our spaceship is starting in the middle at 120, and the alien is starting off screen at position 0. All right. Now we have to define our missile. Now, let's go back to the graphic and show you the player missile graphics block of memory. You'll see that the missile is, all 4 missiles can be defined by 1 byte. Each missile is 2 bits. So you've got missile 0, 2 bits, missile 1, 2 bits, missile 2, 2 bits, and missile 3, 2 bits. By setting 1 byte, you can define the look of each one of the missiles. Now, I know this is not difficult, but believe it or not, you can have a missile that is 1 bit or 2 bits to give it that little extra width. Or you can combine all the missiles together, turn all the bits on, and have 1 wide missile. So in our case, we're going to be using missile 1, which is the second one in. And if we want to turn both of his bits on, we're going to use the number 12. So that's why we have here missile 1 equals the player base plus 768. That gets us to the beginning of the missiles. And we're poking M1, and we're setting his initial position down. Okay, vertical position of M1, comma 12. And that's the bitmap data for our missile. It's that easy. Okay, and then we're going to initialize his horizontal position, which is memory location 53253, to what we have our variable horizontal position M1. All right, and here's our main loop. So before we go into our main loop, let's do a quick review. So what we did was we set up our player missile graphics base. We enabled our graphics mode. We drew the background. We set the color for our players. We cleared the memory for our players. We loaded the bitmap data from our players into their respective part of memory. We set their initial positions, and we're ready to go. So everything on the screen is ready to start in its initial position, okay? So let's look at line 530. Now, line 530 through 590, this is pretty much the main loop of our program. And if you want to think of a game program that's running continuously, you're always going to have what we call a main loop. A main loop is going to be doing the basics. It's going to be checking inputs from the keyboard or joysticks, It's going to be updating positions of players on the screen. It's going to be playing music. It's going to be updating the background display. So everything happens in a continuous loop. All right. Think of it as a movie strip. In a movie, everything happens one frame at a time. Nothing happens all at once. It's one frame at a time. Same thing with the game's main loop. So let's look up here and see what's going on. All right. So the first thing we're doing in our main loop is we're saying if the vertical position of our missile 1. Now, remember, our missile 1 is going to start from the tip of our spaceship. What we want is when we hit the fire button, we want that missile to appear at the nose of our spaceship and go up, okay? So that initial position of the missile is going to be pretty much the tip of wherever player 1 is. So for our example, I know that our player 1 is 220 lines down always. He may be going left and right, but he's always 220 lines down the nose of him. So the reason I have this as the first line is I'm saying if my missile position is greater than 1, meaning that it's not 0, that means that I've done something with that position. It's on the screen, because when we start off with this program running, the position of missile 1 is 0. We've initialized it to 0. So by the fact of this being more than 1, this main loop knows that the missile is already in motion. It's already been fired. It could be anywhere between 1 and whatever, but we know that if it's greater than 1, that it's been fired. So what I did was I said, if it's greater than 1, I know it's in motion, go to subroutine 902. Now, let's look at 902. 902. Here we have our machine language routine called move player up or move missile up. It works for both. And I'm giving it missile 1's location in memory, its current position, -1, comma 1. Now, what this translates to is this is going to move my missile 1 line up. In other words, the missile's in motion. I need to keep it going in motion. I'm going to move him 1 line up. As soon as I do that, I'm going to take his vertical position and subtract 1 from it. Because if he starts at 220, when I move him up, he's going to be at 219, right? If he's at 219, I move him up, he's going to be at 218. I got to keep track of where he is in memory, so the next time I come around to move him, I know where to start. Now, at the same time, after I move him, the wall. Let's talk about that orange wall that's at the top of the screen. Now, in the Atari Player Missile graphics system, you can detect when a player hits a player, in other words, 2 spaceships collide, or an alien in a spaceship, or whatever you have them designed as when they touch. You can also detect if a player, meaning our spaceship, touches a background, like a stripe or a piece of grass or a planet. You can detect player-to-player collision, okay? You can also detect player-missile collision. The only thing you cannot detect is a missile hitting a playfield object or a background color. So in order for me to detect if that missile that I've shot up is going to hit that wall, the wall is not a player, I have to basically look at the missile's position, which I do here in 908. I say if the vertical position of the missile is 95. Now I already know ahead of time that 95 is the bottom of that orange layer or the ceiling, okay? So I'm saying to myself, if that position of that missile is 95, then I'm going to do something. I know that I've touched the wall. So immediately I go sub 2500. Let's go to 2500. And 2500 actually punches a hole in that orange wall. And what I do here at 2502 is I grab a position along the wall based on the position of the missile. And this calculation here is basically calculating from the player missile coordinate system, vertically and horizontally, down to the 40 columns of graphics mode 3, so I know which brick he's touching. So I basically get the horizontal position in the wall, and I locate that position. If you don't know what the locate command does in BASIC, locate gives, you give it an X and Y coordinate and a variable for the color. and it will basically go X and Y on the screen and tell you what color is located at that screen. Now, the reason I do that is because if I've already shot a missile and I've struck that part of the wall and it removed that orange color, there's no reason for me to blow it up again or destroy it again. So what I'm saying is locate where the missile touched. If it's 0, do nothing, just return. We've already blown that part of the wall up. Otherwise, we're gonna set the color to 0. We're gonna plot at that position where we touched. And we're also gonna plot at that position -1. We're gonna give a little bit bigger of a hole in the wall in the block. So basically we're gonna blank out the block that it hit, and we're gonna blank out the block next to it that it hit. Okay, so if the missile comes up, we're taking 2 squares and we're knocking them out. While that's done, we're gonna go sub 2000, we're gonna make one more jump, and we're gonna create this sound here. And this sound right here is our little explosion sound. So we're gonna go through and do our little quick sound. It's actually using 2 voices, sound 0 and sound 1. And with a little delay. Actually, we could probably shorten this delay as it's kind of long right now. And then we're going to return. All right. So I know that was a lot to absorb very quickly there. I hope my explanation made sense. But this first line is important because before we get down to start reading, you know, joystick movements and fire buttons, we have to, every time we come in the main loop, we have to assume that there's been a missile that's already been fired and we need to keep it going. Because remember, this is a continuous loop, all right? We can't detect the fire from a button and see the missile all the way through before we come back to the main loop. Otherwise, we would never have response to our joystick or movement of our other aliens. In your main loop, you want to make sure that you're taking care of multiple tasks, you know, on the rhythm. In other words, in a loop. If you focus on one task and branch off into a subroutine and just worry about that one task, the rest of your UI, the rest of your game is going to freeze, and you're not going to have any input from your user. All right, so moving along, let's talk about line 536. 536 reads the trigger of joystick number 0, which happens to be joystick port number 1 physically on the computer. So we're going to read the trigger and store that in a variable called trig1. Now, while our main loop is going on, we have to worry about, or we have to make sure that we maintain that alien going across the screen continuously. We don't want to show him stopping or having interruptions. So line 537 says the horizontal position of player 2, which is our alien, is equal to its position plus 1. So we're going to move the alien one position to the right. If his position is greater than 240, meaning that he is off the right side of the screen and no longer visible, then let's reset his position to 0. So we're going to move him 0, 1, 2, 3, 4, 5, 6, and so on until he gets to 240, which is off the screen. And then we're going to bring him back to 0 and start him all over again. So as our main loop is running, this guy is just continuously moving to one edge, starting over, moving to one edge, starting over. And as soon as we update his horizontal position, we're going to poke that into 53250, which, according to the Atari handbook, the mapping the Atari, 53250 is the horizontal position of player 2. I always like to refer back to mapping the Atari because at the end of the day, guys, this is, I'll show it again. I've shown this in other videos of mine. This is one of the most important books you can have for your Atari. Mapping the Atari. Okay, thought I'd just give a plug there for that. Okay, so we've read our trigger, we've moved our alien, and now let's get the position of the joystick and assign that to stick 1. Stick 1 equals stick, open paren, 0, close paren. That's going to read the joystick position for joystick number 1. Now, I commented out line 550 and 560. These, we used them in the prior version of this program to move the alien up and down, but I remarked them out because in this demonstration we don't care about moving them up and down. Let's move on to line 565. Line 565 says if the trigger is 0, meaning that when you press the trigger on a joystick you get a 0, okay? So if we have pressed the trigger, we've pressed the trigger on the joystick, go sub routine 900. So as you remember, 900 is that subroutine that moves the missile. All right. So again, horizontal position of missile 1 equals, now this is where we are initially firing the missile. Okay, this is not the routine that continued the moving of the missile if it was already in motion. This is the one where we're actually firing a new missile. So we are going to say our horizontal position of our missile, all right, is equal to the horizontal position of player 1. Now, player 1 is our spaceship, okay, and as you know, we're able to move that spaceship left and right along the screen. So the minute we hit the fire button, we want the missile to appear right at the nose of the spaceship, okay? So how do we do that? Well, we take the horizontal position of the spaceship and we add 3 to it. Our spaceship is 8 bits wide, okay? So we want to start at the left of the spaceship and move in 3, which is going to give us pretty much right in the center. And that's where we want the horizontal position of our missile to start. So now we've got the horizontal position starting right in the middle of our spaceship. We want the vertical position, VPOS M1 of our missile, equal to 218. Now, as you remember, I initially set the vertical position of our spaceship to 220. So if we want the missile to appear at the nose of our spaceship, we're going to just back it up 2 scan lines. So if this is the tip of our spaceship, we want the missile to appear just on the top. So that's where I got the 218 from. Vertical position of missile 1 is 218. So now we have a horizontal position and we have our vertical position. So now what we want to do is we want to poke in memory missile 1 plus its position a 12. That's going to set the 2 bits of the missile in memory to on. Now we have our missile sitting at the top of the nose of our spaceship. And we're going to poke 5-3 to 5-3, which this represents the horizontal position of missile 1 with horizontal position missile 1. So now we've turned on the missile and we've moved it horizontally right on top of the nose of the spaceship. Now, once we've done that, we are going to basically call our machine language routine, which moves a player or a missile. We're going to say missile 1 plus his vertical position minus 1. In other words, we want to move him from where he's at to his position minus 1, and we're going to move it one scan line up. So we're going to take the missile and move it ever so slightly 1 scan line up. And then, as always, when we move something, we update its position. Vertical position of missile 1 equals the vertical position of missile 1 minus 1. Okay, does everybody see how that worked? And then, obviously, right after we move it, we want to detect and see if we've collided with the wall. And this is where we've talked about now, if the position of missile 1 is 95, which is the bottom of our wall, the orange wall at the top, then we're going to go ahead and we're going to blow the hole in it, and we're going to make that sound, and then we're going to return back, and all is good. So let's go back up to our main loop. Again, we're dissecting the main loop. We're seeing what's happening. So now that we've taken care of if a trigger is pressed, let's go down here and see if our joystick is pressed left, which I know happens to be if stick 1 is equal to value 11. So if we've moved the joystick to the left in our main loop, we're going to go to our subroutine, which is at 770. And basically, this is where, and this is old news, we've done this in our last program, we're going to move player 0, which is our spaceship, to the left. So we're going to say the horizontal position of player 1 equals the horizontal position of player 1 minus 1. Now, what I did differently here is I'm checking to see if the horizontal position is less than 48. 48 happens to be the left side of the screen that is in line with the wall, if you will, or if you will, in the border of what's visible on the Atari screen. So I'm saying if the position is less than 48, then set it to 48. We're not going to allow the spaceship to go off the screen anymore. We want it to basically stop at the left border of the screen. So that's what this is doing. This is taking the horizontal position of what it is, subtracting 1, checking to make sure that it's not going off the screen, and then we are actually going to move it with a poke 53248. 53248 represents the horizontal position of player 0, We're poking that with the new horizontal position of P1. So we're taking the spaceship and we're moving them over, you know, one move to the left, and then we're returning. All right. Let's go back up to the main loop. And we're going to read the next line, which is line 580. If the stick is equal to 7, which means we are moving the joystick to the right. Okay. That's going to be a value of 13. We're going to go sub. Actually, I'm sorry. If stick equals 7, which means a right movement, then we're going to go sub 820. So again, this is old news again, 820. If we're moving the player to the right, we're taking his horizontal position and we are adding 1 to it and reassigning it back to it. This time I added if the horizontal position is greater than 200, meaning that if we are off the screen, or if we are near the edge of the right-hand border, then just set it to 200. So this here, if the horizontal position of player 1 is greater than 200, then just set the horizontal position to 200. That spaceship's going to move over to 200 and stop right there. Because every time he gets there, he's just being reset to 200, 200, 200. It'll never go past 200. And then we're poking 5, 3, 2, 4, 8, which again, horizontal position of player 0 with the new horizontal position. And then we are returning. All right. Let's go back up to our main loop. Is there anything else that we need to do? No. So once we've handled all that, then we go back to 530, which 530 is the top of our main loop. So if we isolate this area of the code, this is our main program loop right here. Okay. So from here to here, we are handling all of our inputs. We are updating our players, we are updating our missile, we are updating our alien, and we're just looping continuously and making updates as necessary. Okay, so let's run the program again. Here's our left movement. Here's our right movement. Now, if you watch that green alien, you see he's going across the screen pretty smoothly. As soon as I start to do something with the joystick, you can see him slow down. I don't know if you can see that on the capture device. Fast and smooth, as soon as I do something, he slows down. That is the problem with basic and writing games. Now, if I launch a missile, you'll see everybody slow down, and if you combine that with joystick movement, now look how slow everybody's going. It just, I mean, it really slows everything down. And this is why it's almost impossible to have, even with optimization, it's very hard to create a fast-moving, high-paced game in basic. I mean, you know, we're kind of reaching the limits of what we can do here with just 2 players on 1 missile, and you can already start to see things are slowing down tremendously, okay? But, like I said, basic is a great language for learning how to do things at a basic level and getting the concepts down. So that's the reason why we've started this tutorial, and we've stayed with this tutorial in basic. You know, once we get to assembly language, we start drawing these characters and these block walls in assembly language, you're going to see things happening lightning fast. We're almost going to have to probably slow things down. They'll be that fast. All right. So anyway, guys, that wraps it up for this quick tutorial. This was lesson 3 of the player missile graphics. I hope you learned something from it. I hope I explained it clearly to you guys. If you have any questions, give me some comments. If you have any feedback, give me some comments. Hit the like and subscribe button. I think we've got a couple more tutorials to finish up from the assembly language series. Adding and subtracting we did to do multiplication and division, so look for those videos coming up. But I think the next step in this player missile graphics, we're going to go right to assembly language. We're going to start setting up our screen, setting up the player missile subsystem like we did in basic, and actually getting something on the screen and moving it with the joystick, and then we'll be well on our way to creating a high-paced, fast game in assembly language. So until then, we'll see you. Keep programming. Give me some feedback. Let me know how things are going, and we will see you in the next video. Thanks for watching.